Alright, ladies and gentlemen, today we're going to be taking a look at assemblies within SolidWorks. Many of you have not yet dealt with assemblies, so this will be one of your first introductions to assemblies. If you take a look at this mock-up of a simple piston, crankshaft, camshaft, connecting rod, so on and so forth, we're going to be utilizing these separate individual parts and creating them in an assembly. You're going to be responsible for creating the piston, the axis here, or the wrist, the connecting rod cap, crankshaft, flywheel. Alright, so in total you're going to be dealing with around 6 or 7 parts. This is where they should all be mated and finished, what they should look like. And when we're done, you will have 6 parts. As I said, you are ignoring the camshaft at this point. So the first thing we're going to do is you should have a folder on your desktop called Kozlowski_piston. In this folder you'll have a picture, which I just showed you, of the finished image. You're going to have all your separate part files, and if you take a look, the connecting rod cap, crankshaft middle, and some of these other components are separate parts. However, you will notice that the crankshaft here is an assembly. This will be utilized as a sub-assembly when you insert it into SolidWorks. So it's important to note that this right side gear, left side gear, and crankshaft middle are all parts that are already used in this sub-assembly of crankshaft. Okay, so you won't need these individual components if you just bring in the crankshaft, but I needed to contain them within this folder so that the crankshaft as an entire assembly would not be missing individual components. So the first thing in the assembly is when we go into SolidWorks and we say File, New, all right, for the first time we're going to be working within an assembly, not a drawing or not a part. So I'll say Assembly and I will say OK. Now you'll notice when this opens, it's looking for me to browse to insert components. All right. Basically what we want to be doing is inserting individual components into this assembly and building upon those components. The first component that you insert into this assembly is going to be considered the lock or the locked component. In other words, it is that which you will build off everything else. Okay, so I'm going to hit open, and the first thing I'm going to insert is my crankshaft assembly. Okay, that includes all those parts that I already mentioned: right side gear, left side gear, and crankshaft middle. So I'll insert the crankshaft, and you'll see this will come in, and right now I have the ability to move it. What I'm going to do is just click and place that somewhere in the center of the document. And you see that my crankshaft is now inserted, and I can rotate around, take a look at the crankshaft, so on and so forth. The next component that I'm going to bring in, I'm going to navigate once again to Insert Component, Insert Component, and I'm going to browse, and I'm going to look for my for my connecting rod. Alright, so I'll double click and my connecting rod comes in. Okay, what I'm going to do is just place this for now right here so I can take a look at it. So I click and place, and my connecting rod is now brought in next to my crankshaft. In assemblies, what you're going to want to start to do is start to limit the movability of certain components. So right now, if I click Move Component, I can actually drag and move this component around. The whole idea is to limit the areas in which that component can move. That is done so in this particular case by locking or mating certain faces together. So you'll notice down here under our parts tree, for the first time we have this mates. Okay, mates are utilized to lock the components together. So in this particular case, if we take a look at how this is supposed to go together functionality wise, this inner face right here is meant to ride directly on the crankshaft face right here. So what I'm going to do is I'm going to select the faces in which I want to mate, and then tell the computer the style of mate that I want them to be locked together in at. If you just select both faces and say mate, the computer will do its best to default what mate it believes, but it is often best, or is best practice, to go ahead and utilize and choose the correct mate and tell the computer which mate you want to use. To do that, I'm going to click on the face. I'm going to say mate. And for this particular one, you have all these options that you can utilize. Coincident, parallel, perpendicular, tangent, concentric, a lock mate, a distance mate, or an angle mate. All right. Because I'm dealing with two circles or two cylindrical objects, what I'm going to utilize is the concentric mate. Concentric mate is two circles that share the same center point. So if you look, I want these circles to share the same center point. So I'm going to click concentric and then click on my other face or other circle. I'll then check this mate off to hit OK. And you'll notice now when I slide this part, it's limited that it can only slide on the axis of this cylinder. Because these are concentric, they share the same center point. So what that means is this part now can only slide on this axis. I have limited the ability in which this can move. Okay? Mates are all about limiting the ability until it can no longer move. So if you take a look at how I need to limit this any further, I need to limit this so that this cannot slide off of this individual little journal on this crankshaft. There's a couple ways we could do that. The first one being is if you had a face or an edge that we could select here, and we made it coincident with an edge that we could select here, that would allow that to slide in. The other way that we could do this is we could utilize a flat face here, and we could utilize a flat face anywhere else. Let's see if this one works. And set a distance between the two. So it's not that I want them touching, but I want them a certain distance from each other. All right. So we're going to find a distance 0.05, too much, 0.03, where this satisfies and locks this in. If I select this mate and check it off, you'll see I now have a concentric mate and a distance mate. So I'm going to check off that I'm happy, and you'll notice down here at my bottom left under mates, I have concentric, which is shown there of sharing the circle center points, and then a distance mate. If I now go to move this component, it cannot slide left or right. It cannot slide off that axis. The only way this can rotate right now, or the only way this can move, is rotating on this connecting rod, which is exactly what we want. The connecting rod can rotate on the crankshaft. All right. Next thing I'm going to do is just save this somewhere. So I'll save this as an assembly. We'll rebuild it, and we'll save it to the desktop, and I will call this piston _ assembly. Next part I'm going to bring in, I'm going to insert component, and I'm going to browse to my desktop to that Kozlowski piston folder that I spoke about. And we're going to bring in the connecting rod cap. This is the bottom cap that you would connect around the connecting rod to hold the connecting rod on the crankshaft. So the first thing I'm going to do is I'm going to once again select this face, mate this with a concentric mate as it's done. Check that off. This part can now once again move about that axis. All right. But it has the ability to slide all the way over here. Okay. What I'm going to do is there's a couple ways you go about doing this. You could use the distance mate that we just did again to put it from a distance from something. You could have this face, you could have this face touching this face, or I could solve all of this by just saying, let's take this circle right here and mate that with a concentric mate to this circle. What you'll see what that just did is it's actually lined up this pin or the cap exactly where I need it. Because those circles were modeled in the correct spot, that is now tied to that, and that is tied to that. So these axes of this circle and this circle have just locked this component in. So now we have a connecting rod that spins on our crankshaft that has the bottom cap with the oil slinger. Okay, exactly what we're looking for. Next thing I'm going to do is I'm going to bring in my piston axis. This is actually like the wrist pin. Okay, they call it the piston axis. So once again, we're going to use the concentric mate. Mate this concentrically with this. Check. And the next thing I want to do is get this centered. All right. So what I could do, if I really wanted to, is I could take this part, measure the length of this part, and divide that by 2 basically. Measure this part, divide it by 2, and then figure out the width of this part to space that correctly. But on a true piston, this does have the ability to move slightly until it's put in the jug of the motor or the cylinder. This has the ability to slide a little bit. Okay, but for our model, what I'm going to do is I'm going to take this, mate a distance from this face, all right, and I will put that at a distance that is roughly centering it. That looks pretty good right there. Okay, doesn't have to be exact at this point. All I've done is limited the ability for this to move out of there. Okay, this can still rotate on this axis, but it can't slide left and right. Okay, now what we're going to do is we're going to bring in a component, and for this we're going to bring in a piston. So I'm going to browse for my piston and bring this in, the piston head itself. And at that point, once again, I'm going to make this concentric with this. So what I'll do is I will mate this concentric with this. Okay, check that off. And now you can see once again it's sharing the axis. And what we have to do is get this piston oriented in a way that locks everything in. There we go. It's not looking half bad. So what I can then do, once again, is I'm going to find a flat face, which I think this face we can mate over here. So I'll slide this over, and I'm going to say this face, even if we go off this face too, mated to this face at a distance. And we'll draw that in until the piston is sitting exactly where we need it to be. And once again, on a real assembly of a motor, the actual assembly, this would all be corresponding to the cylinder in relationship to the crankshaft. So this piston would have the ability to move slightly left and right, and the wrist pin would be locked in by retaining clips of some sort. Check that off. And if we take a look now, we have a piston that can move on our crankshaft now. And this is exactly how a piston would function until it's placed in a cylinder or a bore of a motor. Okay? So the next thing that I'm going to do is I'm going to bring in my insert component, and I'm going to bring in a flywheel. Okay, so you see my flywheel here. We will bring that in. And if you notice on the flywheel is going to go onto this tapered section down here. All right, and this is the side that faces away from the piston. This is the side with the taper here that slides onto this. You'll also notice that the flywheel has a groove for the keyway. So we'll have to line up the keyways. All right. First thing I'm going to do with any circle, obviously, is go after my concentric. Even though it's tapered, it still does have an axis that runs through the center of that taper. So I'm going to click on this, and I'm going to say mate concentric to that. All right. Just so happened that it's spun in the correct direction, which is good. And what I will then do is, once again, we're going to put a distance from this face, let's find a flat face, to this flat face at a distance. Or we could go to this flat face at a distance. So I will do that and do a distance mate from here. And we're going to step this up to a point in which the taper looks as though it's fitting correctly. And we'll take a look at the back side. Looks like I can come back a hair. And then we would ultimately have some way to thread something on here to tighten this up. Oh, maybe we gotta go on this side, I'm sorry. So we're gonna actually put the flywheel back over on this side. So what I'm gonna do to change that over now, I'm actually gonna close this mate off. Okay, and if you look, I can keep this concentric and bring it right through the whole part, but now it's backwards. So what I'm gonna do is I'm actually gonna come down to my mates here, highlight my concentric mate, and right click and say delete mate. Now I can go ahead and rotate this component once again by going to move component, rotate component, rotate that around 180 degrees, check. Axis, mate, concentric, axis, check. And we're gonna bring this flywheel on to where it should be. That looks nice there. So we'll do a distance from this top face, and we will get that right where it needs to be, right around there. And then what you would do is have a nut that would come on and hold this flywheel on to its taper. But we also need to address this keyway. So if we look at this keyway now, I need to rotate this around until we find that keyway that lines up, which I'm having an issue finding. There it is. And what we could do, you could see those keyways would slide right in there. So what I'm going to do is I'm going to use a couple different mates here. I could say this face, which is the flywheel, and this face, which is the face on the shaft, I want coincident. I want them on the same plane touching each other. And when I check that off, you'll see now those keyways are lined up perfectly, where if you were to have a keyway inserted in there, that flywheel would be associated with that keyway, and we could go ahead and drop the nut onto that shaft. Okay. Check this off. And we should still have our piston good. Okay. So as our piston would be pressed up and down, the flywheel would rotate, excuse me, the crankshaft would rotate, causing this to spin as well. All right. So if you take a look now, we have component-wise, we have crankshaft, which is one. We have the cap to the connecting rod. We have the connecting rod itself. We have the wrist pin or the piston axis. We have the piston and the flywheel. We have no rings placed on this, but if you can take a look, this is where we want to get to at this point. Okay, you can see all the mates that I've utilized, many concentrics, a couple distance, and the one coincident mate. Okay, so over this particular assembly, we used 3 different style mates. But if you take a look at the style mates within the standard mates, these are all mates you can use. Parallel obviously puts them on parallel planes. Perpendicular is at 90 degrees. Tangent is coming off that circle, just as you see there in the diagram. The lock component will lock 2 components together in relationship to each other. So I always tell people to use a lock component as a last really effort, but in all reality you should be utilizing some of these components, whether it's an angle, a distance, a concentric, a tangent, so on and so forth, to really get these functioning together. So that's how we go about lining up the connecting rod, piston, shaft, so on and so forth. Hopefully you've learned something about assemblies in this lesson, and good luck.